Can you confirm? Can you see the share screen?
Yes.
Yes, we can see.
All right. Thank you, class. Class, a quick note as usual. During the lecture, if you have questions, you can drop in the chat. If you don't want to talk, okay, drop in the chat. If you cannot hear me properly due to probably bad internet connections, also please let me know. Drop in the chat or interrupt me. All right. Don't stay silent. If you have any difficulty, do let me know. All right. It's 6 minutes already. So let's start our lecture. Class. In the last 2 weeks, we only review statistics core concept and doing some hand-on exercise or introductions to data. I have not introduced you to the real econometrics lecture yet. Start from today, we are going to discuss more with econometrics topics. In the last 2 weeks, we discussed some descriptive statistics. We discussed variability. You learn about covariance. You learn about variance. You learn about correlations. And in that case, correlation and covariance only show you the relationship between two variables, but not the effect from one variable to another variable. In other words, it does not tell you causal relation. It does not tell you the dependent variable or independent variable. So to summarize from the last 2 weeks, you should at least understand what is variance, what is correlations, what is standard error. When we discuss about sampling distribution, you should know what is standard error. You should also learn about sampling. We discuss a little bit about sampling. All right. So before we move on, does anyone have any questions about last week's lectures? Any question that you have before we move on? Please ask now. Question, please, before we move on. Also, let me know if I am fast. All right. No. So I assume no. So let me repeat this again. It's important for you guys. If you don't know what that is, I mean, you should understand or learn about variance, correlations, covariance, and standard error, because that statistic is going to be used, or we need that statistics to explain some equations in econometric model. So again, I will not spend too much time on mathematical equations, but rather going into the main points and connect it with applied work. All right. So as I said again, as I said earlier, we indeed know that covariance and correlation could tell us the relationship between two variables, but we cannot make causal interpretation. We cannot say X cause Y or Y cause X with correlation and covariance. We only want to know whether the two variables go on the same direction or go in opposite direction or no relationship at all. Okay? Class, I ask you guys to form a group and develop a research question and objective in mind. Remember that? Do you remember your research question and objective? Your group research question or objective? In that case, okay, you also want to assess the relationship between two variables. But to be specific, we will later want to estimate the effects of one variable to other variable. So what I am saying is that we cannot simply use correlation to answer your research questions. We need to do some other analysis, fancy analysis to answer your research question. Now, before we move on, please go back to your group research question and objective and remember that. Remember that. What is your research question? The relationship between price and quantity demanded. Even though your research question and objective is the relationship between price and quantity demanded, you know that price is the main factors that may affect quantity demanded. So in this case, we know what is the cost, what is the effect. We know that the change in price will change in quantity demanded. Okay, so rather than simply know the directions, the opposite direction or the same direction, or rather than just simply use correlation, we are going to discuss about regressions. Today, we only discuss the first part of simple regression model. So before we move on, what do we mean by simple regression model? The term simple regression model here have two important properties. The first property is that there are only two variables. Only two variables. But in this case, we specify independent variable and dependent variable. The second property is that both variables must be numerical or continuous. Okay, so whenever we talk about simple regression model, we have two variables, independence and independence, and both variables are numerical or categorical variable. Because on week 9 or week 10 we are going to discuss, regression model with qualitative information. All right. So now let's move on. So with simple linear regression model, we write it like this. Okay. So we try to explain variable y in terms of variable x. As given my earlier example, you want to know x, the price, how it affects quantity demanded, which is y. Okay, so normally in mathematics, it is written like this: y equal delta 0 plus delta 1 multiplied x plus u. What is y? Y is known as or called dependent variable. Why it is dependent variable? Because y here depends on x. Okay, so the term itself reflect the meaning. All right, so y is dependent variable. Why we call it dependent variable? It depends on this equation. Specifically, it is conditional on x. It is depending on x. So sometimes it is called dependent variable, some call explain variable, some call response variable. But in short, y is the variable that is affected by some other variable. Okay, this is what delta 0 is known as intercept. It's known as intercept. Okay, x is known as independent variable. Why it independent? X is not affected by y, but x affect y. Y depends on X. So X is independent variable. X is independent variable. Right? What is delta 1? Delta 1 is the slope of parameter. What is the slope of parameter? This is the coefficient that we all want to estimate. For instance, we want to know the relationship between price and quantity demanded. So X is the price, Y is the quantity demanded, and the effects of Y, the effect of X on Y is found with delta 1. Okay, delta 1 is the coefficient, is the estimate, is the parameter that we want to estimate. How much X effect on Y is interpreted with this delta 1. What is mu here? Mu is error term. It commonly called error term or disturbance or unobserved variable. So what do we mean by this? It means that if you look at these equations, Y here is only analyzed by the change in X. But there are some other factors that are not included in this model. And those factors are included in this U. So they are unobserved variable. This equation only includes one independent variable. So those independent variables that are not included in this model are all in mu, which we call unobserved variable. So in the real world application, mu is not calculated. What I mean is that we cannot interpret this mu. Okay, so again, this simple regression model only analyze the relationship between X and Y. In other words, we want to assess the effect of X on Y. So delta 1 is the effect of X on Y. But there are other factors that also affect Y, but are not included in this equation. And they are all called unobserved variable, which is in mu. Okay. Hopefully you guys follow the term. Delta 0 is intercept. Delta 1 is slope of parameters that we want to estimate. To know the relationship between X and Y here, we need to estimate delta 1. For population, we always call slope parameter for population. Okay, remember last week, we always call parameter for the calculation for population. Calculation for sample we call statistic in general, but with this, next we will call it estimate. This delta 1 we call estimate for the sample, the estimate from sample. Questions? Follow me?
Yes, sir. I understand, sir. But how do we determine the slope or the intercept, sir? Is it come from the exercise or we determine ourselves?
All right. So you mean how do we compute or calculate delta 0 and delta 1? Is that correct?
Yes, sir. Correct, sir.
Right. So this is the main. This is the main topic for this course. Okay. This is the main concern for this course. So in this course, we try our best to estimate the real delta 1 and delta 0. So during this remaining week, we discuss various topics. How do we come up with the best delta 1? We will discuss it later, okay, step by step. But what I'm going to say is that we try our best to estimate a good delta 1. So your question will be answered by this course, not now. Okay, so we basically only have X and Y, but we don't have delta 0 and delta 1. That's what we are going to compute. Good question, but that needs to be answered by the course.
Thank you, Chair.
All right, any other questions? All right, next. So again, the interpretation of simple linear regression model is how y vary by changing it. So in equation, this is the cell tau y, which is the change in y conditional on the change in x. All right. So delta 1 is our main concern. It's our goal to compute delta 1. Okay. It's our goal to compute delta 1 because this is the conditional expectation. But I say conditional here because we want to know why by, we change in x. If there is a change in x, with the change in y, we got delta 1 from equation. But if we change in x, there is no this mu here does not contain x, so it is 0. So with this equation, we mainly interpret this beta 1 for the relationship between x and y. Okay, so our main concern again, how much this delta 1, and we interpret it as how much that's dependent variable change. How much that dependent variable change if independent variable increase by 1 unit. Okay, so it is important to know the measurement of both x and y. You need to know what is the unit of variable x, what is the unit of variable y. You will see in the few slides, we will interpret this coefficient, and it's mainly depending on the unit of x variable. And for this one, the interpretation only correct if all other things remain equal, if independent variable is increased by 1 unit. So normally, in short, for now, you don't have to care about this yet, but your main concern is delta 1. Okay, so here we only look at the effects of x on y, and in our equation we only have one independent variable, one dependent variable. But in real world, there are many independent variables that also affect y. So why we only first start to look at only effect of one x on y? Okay, so normally, in reality, the simple linear regression model is rarely applicable in practice. Why? Because it is not true to only observe one variable x on y. There are many other. We should include more. But this is a starting point that help you to understand mathematical equation, how we compute, how we calculate delta 0 and delta 1. If we have many more independent variable here, it is more complicated. So we start with a simple model. But again, in practice, we rarely conduct any analysis with only one x. Okay, this is just the purpose for a better or easy understanding how the equation of delta 1 and delta 0 is derived from. Okay, here is an example. All right, for example, you want to look at the relationship between fertilizer and soybean yield. Okay, if you use correlation, you simply know they are in the same direction or both or opposite direction. But it's better to use regression model. Here we know that x is the cause and y is the effects. So the change in fertilizer will affect the soybean yield. Okay, so we measure the effect of fertilizer on yield, holding all other factors fixed. Okay, we are assuming that all other factors fixed in this regression. So only fertilizer affect yield. But again and again, other factors that may affect yield are not yet included in this equation. For instance, rainfall, land quality, presence of parasite. Okay, so this holding other factor fixed is not really true at all. You cannot say that, okay, we want to see how much the fertilizer affect yield by assuming that land quality fixed or land quality is the same for every observation. When you use more fertilizer, land quality normally change, right? So you cannot hold it constant at all, hold it fixed at all. it's better to also include it in this model. But again, this is just the first step. For now, we only want to assess the effect or the association of the change in fertilizer on soybean yield. Why we say this simple linear regression is not really practical? Because there are other factors that are not included in the model. So they are unobserved variable, they are just in yield. Another example is the rate equation. In simple term, economics always try to their best to estimate what we call return on education. So what is that return on education? Economists try their best to estimate the relationship between education and rate. If they simply want to assess the relationship, simply the relationship between education and rate, that's very simple. But you know, from the past until now, there are a lot of paper, scientific paper, has been published that they aim their best to construct the best delta one. Okay, economists try their best to construct delta one. In this example only, we only introduce education as the single variable in this equation on wage. So we simply want to measure the change in hourly wage given another year of education by holding other factor fixed. Okay, here only two relationships, but in reality there are other factors that affect wage that should be included in the model. Okay, so for instance, intelligence. Okay, intelligence. So here you assume that you study the effects of education on wage by assuming that intelligence is the same for everyone because you do not include it here. But this assumption is not really correct if you do not include it in the model, right? Because normally a person who had higher education tend to have higher intelligence. At the same time, those who earn more also tend to have higher intelligence as well. So this variable intelligence affects both ways and correlate with education. Later you will see some term that we use. What do we mean? What is the problem when we do not include intelligence in the model? All right, so let's discuss it later. But for now, we only want to look at the relationship between education and weight. Other variables are not included. They are unobserved variables. They are error term. They are disturbance. Okay. So if we only estimate the equation with this one independent variable, education on weight, fertilizer on yield, can we make causal interpretation? Can we say exactly how much delta one is really affect on yield? Can we really say that? Because as I said from the beginning, we try our best to produce the best delta one. But in this equation, we only introduce one independent variable. Can we really say that if we increase fertilizer by 1 kilo, for instance, how much it change on yield? Can we really say that? That we mean by causal interpretation. Can we really make causal interpretation? When is there a causal interpretation? Okay, to make causal interpretation, class, the regressions need to meet what we call conditional mean independent assumptions. What is that conditional mean independent of assumption? We need to make sure that the error term in these equations is not correlated with this U. How do we know that? Normally, if you conduct more literature, you know that. For instance, now you already have research question and objective. When you do more literature review, you know that what are the factors that affect yield, for instance. But if you want to assess the fertilizer on yield, what are the factors that you should include in the model? If you include all the variables that affect yield and correlate with this fertilizer, you can make causal interpretation. You can say how much fertilizer affect on yield. But if you do not include all relevant variables that affect Y and correlate with X, you cannot make causal interpretation. Technically, we say conditional mean independent assumption is violated. Okay, to make causal interpretation, make sure that all the variables that you do not include in the equations, but they are in menu, are not correlated with x. That's what I said. That's what it's meant. Okay, the explanatory variable must not contain information about mean of unobserved variable. Okay, for instance, we want to estimate the effect of education on wage, but the wage here is affected by intelligence. Education itself also correlated with intelligence. So if you do not put intelligence in this equation, the delta one that you estimate is not the coefficient for education itself. But this delta one here is also include the coefficient of intelligence. Again, because intelligence affect weight. Normally, those who have higher weight, they are more intelligent than the other. At the same time, those who have higher degree also have higher intelligence. So this intelligence here affect Y and also correlate with education. When you do not include intelligence in the model, this education itself is contaminated. This education, the delta one for education here, also include the delta of intelligence. Okay, so here we cannot make causal interpretation. The conditional mean independent assumption here is unlikely to hold because individual with more education will also be more intelligent on average. That's what conditional mean independent assumption mean. Questions? How are you?
Hello, lecturer.
Yep.
I'm still not pretty sure about the intercept and slope parameter, lecturer. So what are they exactly, and are we going to calculate that as well?
Right. Because this is just a starting point, you will see it. I will try to explain you later with numerical example. So I hope I get back to your question later with the numerical example so that you will understand better. So now we just start with the mathematical foundation and equation first. Is that okay?
Yes, lecturer, yes.
Right. So we will have numerical example on that. The delta one here, this is delta 0 intercept, and then delta 1 here. So we will get back to it later. All right.
Sure. I have a question as well, sir. Can you
Yep.
go back to the last slide, sir?
Here.
No, last one, sir.
What do you mean?
Slide number 3, sir.
Slide number 3. I think I am now on this. I think now I am on slide number 3.
Oh, now you are on slide number 5, sir.
Oh, it is not moving back.
Yeah, sure.
Okay.
How do you pronounce the symbol in front of y and x? Is it delta?
If I understand, if I remember correctly, it's delta.
Delta.
Right,
Oh.
right.
So it is different from delta, right, sir?
Yes, they are different. It's just notation, but you just need to remember the delta y here. This is just like it's mean the change in y divided on the change in x. So given x, the change in y is given on the change on x. What does that really mean?
Because delta is also referred to the changes as well. That's why I asked you.
This delta, you mean delta here?
No. The h and y, sir. Because when
this
I study in high school, they use delta to refer to the changes.
Right. But the delta, that mathematical notation is for a bigger change. A delta here normally is a small change.
Oh, okay. Understand now, sir.
Yep. So you will see it in somewhere we with population parameter we use delta. Sometimes we use delta with the small change or bigger change. All right, class. Hopefully you understand what do I mean by causal interpretation. All right. So that is why earlier we said that it is rarely in practice to use simple linear regression. Why? We cannot make causal interpretation. But I tell you now that even though you include multiple independence into the regression, it's still that this conditional mean independent assumption is rarely met. It's rarely met. It's rarely met. And normally with just a regression, we cannot make causal interpretation. And later you will know why I request all of your group to formulate a research question and objective by specifying the relationship between two variables because of this equation. Assuming that if you want to say to determine factor affect Y, then there are a lot of factors that affect Y. Here in the econometric, you cannot address all the assumption of that X. But here in your objective, you only have one X. You just need to know what are the unobserved variables that may affect this specified X. You may not understand now, but later I will explain you. I have a clear objective why I requested you guys to formulate a research question or objective with specific relationship in mind. All right, question with this causal interpretation. For now,
Yeah.
in simple,
Teacher,
you cannot. Yep.
Teacher, I have one question. Teacher, can you re-explain the term conditional mean independence assumption again, teacher?
Okay. Here is we call conditional mean of assumption. And you know, if you don't know what is the E, we call expectation. And if you don't know what is that expectation mean, refer back to last week material. We have expectation of the mean in that equation. So basically it is just an average, right? But here, when you calculate the average itself, they are average, what we call unconditional average. But here this is conditional. Conditional here meaning given X. But in this assumption itself, it means that, for instance, you look at this example. We want to estimate the effect of education on weight. All right? We want to assess the effect of education on weight. But in this equation, we only have education as independent variable. There are some other variables that affect weight and also correlate with education. But for example, intelligence. Now, in this equation, you do not include intelligence. In reality, intelligence affects weight, meaning that those who tend to earn higher weight, they have higher intelligence. Also, those who finish higher degree tend to have higher intelligence. If you do not include intelligence in your model here, this beta 1 here is not the coefficient of education, but this beta 1 here is the coefficient of education and intelligence, because you do not include intelligence in the model. In other words, education here is correlated with you because intelligence is in you. So this conditional mean independent assumption mean that the explanatory variable that we are interested in here is education must not contain information about unobserved variable factor. But education here, because we do not include intelligence in the model, it means that the beta 1 that we estimate here is not the coefficient for education itself. It is also the coefficient that may be affected by intelligence. So conditional mean independent assumption is unlikely to hold. Why? Because individuals with more education also have higher intelligence, and weight itself also affected by intelligence. So in simple, in our equations, this education is correlated with you because intelligence is not included, it is in you. Do I answer you? Is that clear or still not?
So, teacher, that you can mean a lot of things more than intelligence, but all of the things that you refer to is correlate with education in this example, right, teacher?
So there are many, you are right, there are many other factors that affect weight, all right? But what we find very important is it doesn't mean that all factors affect weight must be included, but all factors that affect weight but also correlate with education. Okay, for instance, if we have experience also affect weight, right? But does experience has something to do with education? No. If experience affect weight but has no a relationship with education, if you do not include it, it is still okay. It doesn't matter because beta 1 is still beta 1 of education. But for intelligence, because intelligence affect both weight and education, if you do not include intelligence, beta 1 here is not the beta 1 for education, but it is the beta 1 of education and intelligence. That's what it means. So you here can have, it includes many multiple variables that are not in the equation. But what is important is that we have to include the independent variable that affect weight and also correlate with this education. So the importance of you here is we need to include all the factor, all the variable that correlate with X. Is that clear?
So teacher, so normally the value of U is given, or do we have to calculate it?
No, normally U here we cannot calculate it. Okay, that normally in the integration we need to make assumption that U is 0. You will learn later. This is just the first step. good that you are serious now. But now we just in the beginning. Later you will learn one by one. Good to start now. Okay, U is something that we make an assumption that U equals 0. Otherwise we cannot generate the equation to have beta 0 and beta 1. Okay, you will see next. Okay, so now let me move on.
Yes, teacher, yes.
All right, so here with the with the conditional mean independent assumptions, we can calculate this equation. Okay, so our original equation is beta 0 plus beta 1x plus u, but with the independent mean assumption, if we assume that these correlations or the expected value of variance given x is equal to 0, we finally have only beta 0 plus beta 1 plus x. This is important assumption. Why? If we cannot assume that the correlation between u and x is 0, it is difficult to calculate beta 1 and beta 0. Okay, so this means that the average value of dependent variable can be expressed in linear regression. But for now, the main important point is that we have one condition or one assumption is conditional mean independent assumption, meaning that u must not correlate with x. If u is not correlate with x, the sum of u itself it will equal 0. Let me go first. So normally, if the assumption of expected u given x equals 0, for any given value of x, the distribution of y is centered around line, meaning that this line here is the expected y, meaning that you can generate y from this equation beta 0 plus beta 1x. Okay, this is the line of this equation, and the real y is around this beta. So if that assumption is true and correct. Okay, so now let's go into some other equation that probably help you to understand more about this. So in order to estimate the regression model, we need data. Okay, so in our simple linear regression, we need x and y. Now, assuming that we have an respondent, or we call observation. Okay, an respondent or an observation. So if we ask the first respondent, we have x1, y1 until we ask an respondent, we get xn and yn. So x here again is the value of explanatory variable, independent variable. Okay, y is the dependent variable. So we have n observation. All right. So x and y, x is independent, y is dependent, and we have an observation. We have an observation. All right. Sorry, I forgot to check the message. I just see it. All right. So, in order to, as we said from earlier, what we really want is we want to estimate the delta 0 and delta 1. All right. So to estimate it, first of all, we try to calculate. We start with the error term. Error term is for population. For sample, we call it residual. All right, class? We call it residual. Now, earlier we call it error term, disturbance, or unobserved variable. That for population. Now we turn to call it the residual. Okay, and that now we have mu hat. All right. So now mu hat in our original equation. So mu hat here is the residual, meaning that the deviation from real y from the y that we predicted from the model. So this is the y minus delta 0 hat. Now because the hat here represent that it is from sample. Okay, originally there is no hat because they are from population. But what we want is that we want to make an inference from sample to population. So now rather than have delta itself, we have delta 0 hat minus delta 1 hat x1. Okay, and then we calculate u, right? So this is our original equation like this. So we just rearrange the equation in order to find u. You have y minus delta 0, delta 1 x, right? And we get this equation.
Teacher, can you go a little slower?
Hello. Hello. Khổ đạch, man.
Bad, Kudat. Can you hear me?
Yes, sir.
I was disconnected for a while.
Yes, sir. I I asked you something, but I don't hear your response.
All right. Wait a minute. The share screen is still loading. Can you see the share screen right now?
Can, sir, can.
All right. What's your question again? I was disconnected for a while.
Oh, I just call you, sir, because I don't hear you talk.
All right. So is that okay? So we was in here. All right. So this equation is originally from y equal delta 0 plus delta 1x minus mu, and now we just rearrange it in order to find mu. But again, earlier equation is error term, but now because we use only sample, we call it residual. Okay, so now we want to find residual. Remember, our goal is to compute delta 0 and delta 1. And in our data, we only calculate, in our data, we only have y's and x. Okay, we only have y's and x. So class, can you hear me now?
Yes, sure.
I was disconnected again. See the share screen right now?
Yes, sir.
Yes, teacher. Teacher,
All right.
Since you're back, can you just explain it from the beginning of the slide because you were disconnected? And can you
Right.
please?
Right. All right. Class, as I said, this is equations. We mainly want to find delta 0 and delta 1, mainly delta 1. All right, we want to find delta 1. So our original equation is, if you remember, our original equations, wait a minute, my device is disconnected. Yep.
Teacher,
Yes.
could you explain us in Khmer so it make us more know more clear about understand clear about this point?
I don't know if your class has a foreign student here. Let me check.
We don't have any foreign student. Like.
All right. All right. So now let's talk in Khmer for this equation first. All right. Slide the ball. យើងចង់កណនីរតំណែងរវាង x ហើយនិង y ហើយយើងមានរូបមន្តមួយដែលយើងមានចាំយើងមានy នេះអត់ចាញ់សុំចាំបន្តិចនៅណា this all right យើងមានរូបមន្តយើងពីដើមឡើយគឺយើងមាននៅណានេះទេយើងមានរូបមន្តយើងគឺ y ស្មើឲ្យ delta 0 បូកឲ្យ delta 1 x plus ឲ្យ mu បាត់កតុយ mu បាទអញ្ចឹងនេះរូបមន្តដើមរបស់យើងមិនអញ្ចឹងទេអញ្ចឹងដោយសារតែយើងចង់រក delta 0 and delta 1អញ្ចឹងយើងត្រូវទាញ mu អញ្ចឹង mu វិញអា mu ហ្នឹងវាត្រូវស្មើឲ្យ delta 1 ដកឲ្យ delta 0 ដកឲ្យ delta 1 x មិនអញ្ចឹងអានេះមិនទៅជាយើង rearrange នៃរូបមន្តរបស់យើងប៉ុន្តែដូចខ្ញុំជំរាបអ្នកទាំងអស់គ្នាអញ្ចឹងថានៅពេលដែលយើងនិយាយអំពី population parameter យើងប្រើពាក្យថា error term បាត់ដោយសារតែអានេះគឺជាអ្វីដែលយើងកណនាមកពី sample ដែលយើងជជែកគ្នានៅ slide មុនហ្នឹងគឺយើងមាន n sample ហ្នឹងគឺយើងហៅវាថា residual អូខេយើងហៅវាថា residual ជាង residual ហ្នឹងគឺកម្រិត នេះវាហ្នឹងគឺវាស្មើឲ្យ y ដកឲ្យ delta 0 ដកឲ្យ delta 1 គុណនឹង x1 អូខេអញ្ចឹងអ្វីដែលយើងចង់កណនារើសំខាន់ជាងគេគឺ delta 1 ហើយនិង delta 0ឥឡូវនេះគឺយើងមានប៉ុណ្ណឹងអញ្ចឹងជាទូទៅនៅក្នុង regression អ្នកទាំងអស់គ្នាគឺគឺមានវិធីសាស្ត្រផ្សេងដើម្បីកណនា delta 0ហើយនិង delta 1ប៉ុន្តែវិធីសាស្ត្រដែលគេប្រើច្រើនជាងគេហ្នឹងគឺគេ minimize sum of square regression residue មានថាគេព្យាយាម minimize square អា u hat I square នេះអូខេឥឡូវយើងមាន u ឯមិនចឹងអញ្ចឹងអ្វីដែលដើម្បីយើងរើ delta 1និង delta 0ឃើញឥឡូវហ្នឹងគឺយើងចង់ minimize sum of square របស់ mu I hat square នេះយើងប្រើយើងរើយក equation នេះយកមកកណនា alright បើសិនមកអ្នកទាំងអស់គ្នាមើលក្នុង textbook មើលនៅក្នុង textbook គេមានប្រើ first order assumption បាទថាគេនឹងឲ្យ equation នឹងស្មើ 0 បាទថាម៉េចយើង minimize វាអញ្ចឹង minimize កាលណាយើង minimize យើងធ្វើឲ្យវាតូចតាមដែលអាចធ្វើទៅបានគឺឲ្យវាស្មើ 0អា square នៃ residual ហ្នឹងគឺឲ្យវាស្មើ 0នៅពេលដែលយើងឲ្យវាស្មើ 0 ទៅដូចខ្ញុំជម្រាបអ្នកទាំងអស់គ្នាខ្ញុំអត់ទៅស៊ីជម្រៅរឿងម៉ាត់ទេបើសិនអ្នកទាំងអស់គ្នាចង់ស្វែងយល់អ្នកទាំងអស់គ្នាអាចស្វែងយល់បន្ថែមក្នុង textbook អញ្ចឹងចុងក្រោយដោយសារតែយើង minimize អា residual sum of square យើងកណនារូបមន្តនេះចុះឡើងយើងនឹងកណនាបានរូបមន្តពីរខាងក្រោមនេះយើងបាន delta 1ស្មើអញ្ចឹង delta 1 hat នឹងស្មើអញ្ចឹងហើយ delta 0 hat នឹងគឺស្មើអញ្ចឹងហើយអារូបមន្តដែលយើងយកមកកណនាដើម្បីរើ delta 1 hat ហើយនិង delta 0 hat និយាយសាមញ្ញថាយើងចង់រើអា delta 1ហ្នឹងខ្មែរយើងគេហៅមេគុណប្រាប់ទិសរបស់ x អា delta 0ហ្នឹងគេហៅអថេអា delta 0មកថាជាចំណុចចាប់ផ្ដើមមួយនៅពេលដែលវាចូលដល់ numerical example ខ្ញុំនឹងបញ្យល់អ្នកទាំងអស់គ្នាទៀតអញ្ចឹងខ្ញុំជម្រាបអ្នកទាំងអស់គ្នាភាសាទៀតដើម្បីកណនា delta 1 hat និង delta 0 hat ហ្នឹងគឺមានវិធីសាស្ត្រផ្សេងគ្នាប៉ុន្តែវិធីសាស្ត្រមួយដែលយើងប្រើប្រាស់តាមរយៈយើង minimize យើងកាត់បន្ថយអា square របស់ mu hat ហ្នឹងអាហ្នឹងគេហៅ OLS ordinary square regression គេមាន step វាផ្សេងទៀតហើយខ្ញុំខ្លាចអ្នកទាំងអស់គ្នាជឿក្បាលដោយសារតែអ្នកទាំងអស់គ្នាអត់មាន strong math អញ្ចឹងអ្វីដែលខ្ញុំចង់ឲ្យអ្នកទាំងអស់គ្នាចាំគឺអ្នកទាំងអស់គ្នាគ្រាន់តែយល់ថា delta 1 hat មកពីណា delta 1 hat គឺយើងកណនាតាមរូបមន្តនេះ xi ដោយ x bar អីគេអ្នកទាំងអស់គ្នា x bar គឺអីគេ x bar គឺ min អញ្ចឹង min yi យើងដឹងហើយគឺជា y ដែល sample ដែលយើងប្រមូលទិន្នន័យបាន i យើងប្រមូលទិន្នន័យបានយើងសម្ភាសមនុស្ស n អ្នកនោះអញ្ចឹង y bar ក៏ជាមធ្យមដែរអញ្ចឹងវានឹងចែកឲ្យ x ដកឲ្យ x bar square អាហ្នឹងគឺវិធីសាស្ត្រដែលយើងរើ x រើ delta 1 hat បើអ្នកភាសាទៀតថាតើធ្វើម៉េចដើម្បីយើងបាន equation ហ្នឹងគឺយើង minimize equation នេះហើយយើងមាន process ក្នុងការកណនាវាយើងមាន assumption ហើយយើងប្រើ first order assumption តែអ្នកនរគ្នាភាសាទៀតអ្នកដែលមាន background math អាច refer បានប៉ុន្តែសារតែគ្នាយើងនៅនេះខ្ញុំគិតថាតាមខ្ញុំដឹងគឺអត់សូវមាន background math ហើយខ្ញុំចង់តែឲ្យអ្នកនរគ្នាដឹងថាតើ delta 1 hat ហ្នឹងកណនាបែបម៉េចហើយនឹង delta 0កណនាបែបម៉េចហើយនៅពេលយើងរើ delta 1 hat ហើយស្រួលយើងរើ delta 0មានអីពិបាកយើងយកតែ y bar នឹងមានរបស់ y ដកឲ្យ delta 1 hat គុណឲ្យ x bar មកបានហើយតោះនេះអ្នកនរគ្នាខ្ញុំអានេះរៀងកាត់តិចបាទថាម៉េចខ្ញុំអត់ទៅស៊ីជម្រៅព្រោះទៅស៊ីជម្រៅ1ម៉ោងក៏អ្នកទាំងអស់គ្នាអត់យល់ដែរព្រោះអ្នកទាំងអស់គ្នាអត់មាន background អញ្ចឹងអ្វីដែលខ្ញុំចង់ឲ្យអ្នកទាំងអស់គ្នាយល់គឺយល់ថាពេលដែលយើងនិយាយពី delta 1ហ្នឹងវាមកពីណាវាមកពី x វាមកពី summation ផលបូកនៃ i ស្មើ1រហូតដល់ n នៃចំនួន respondent របស់យើងហ្នឹង xi ដកឲ្យ x bar គុណឲ្យ yi ដកឲ្យ y bar ចែកឲ្យ summation ឬក៏ថាផលបូករួមនៃ i ស្មើ1រហូតដល់ n ហ្នឹងនៃ xi ដកឲ្យ x bar គុណឲ្យ square អ្នកទាំងអស់គ្នាចាំទេថាអាភាគបែងនេះយើងហៅថា denominator អានឹងជាអីគេចាំអានឹងជាអីគេអានឹងជាចាំពី statistic មកតែអ្នកទាំងអស់គ្នា review អត់ចាំអានឹងជា variance របស់ n ជា variance របស់ x អញ្ចឹងអានឹងជា variance របស់ x អានេះដោយសារតែវាផ្សេងគ្នាប៉ុន្តែអានេះបើយើងមើលទៅគឺដោយសារតែវាបើសិនបើវា x តែមួយទាំងអស់គ្នាទាំងអស់ហ្នឹងគឺវាស្មើមួយបាទប៉ុន្តែវាមិនមែនជា x អញ្ចឹងបានបើស្តៀងគ្នាបាទនេះជា x ដែរនេះក៏ជា variance ដែរអញ្ចឹងបាទនេះដោយសារតែវាមិនមែនជា x ឥឡូវនេះជាអីគេចាំទេអានេះជាអីវាសឹងដូច covariance ចែកឲ្យ variance នៃ x ចានេះជា covariance x គុណនឹង y ចែកឲ្យ variance នៃ x តោះនេះដល់នេះពេលខ្ញុំនិយាយខ្មែរប៉ុណ្ណឹងមានសំណួរអីតាមតនទេស្ដាប់បានទេដូចជំរាបអញ្ចឹងបើស្ដាប់អត់បានជួយប្រាប់ខ្ញុំផងបាន Please, questions.
Xin chị để chị máy hiện sủa sắp chiêng bên để ông lấy chờ hay hiện nhà hiện châu chiêng chẳng chờ. Nên là chờ so vậy tới for this lesson như món like what are the most important points that we need to grab chẳng chờ. Vậy tới for I think there's a lot of equations here and the equation chẳng I forgot a lot. Của em đang hiện tăng từ high school so trong thời gian ai equation thằng ở chờ
ក្នុងមេរៀននេះដូចខ្ញុំជំរាបអ្នកទាំងអស់គ្នាពីដើមគឺខ្ញុំផ្ដោតទៅលើ apply អញ្ចឹងនៅក្នុង quiz ដោយនៅក្នុងប្រឡងដោយនៅក្នុងធ្វើឲ្យដោយគឺខ្ញុំប្រាប់អ្នកទាំងអស់គ្នាទៅរឿង apply អញ្ចឹងគ្រាន់តែដល់ពេលតិចទៀតគឺខ្ញុំនឹង connect វាទៅជាមួយនឹង state ហើយថានៅពេលដែលយើងចង់កណនា delta 1 delta 0យើងកណនាបែបម៉េចគ្រាន់តែអ្នកទាំងអស់គ្នាត្រូវការ foundation ថាត្រូវចាំអានេះថា delta 1នឹងវាមកពី equation បែបណា at least គឺអ្នកទាំងអស់គ្នាត្រូវចាំអាហ្នឹងដែរអ្នកទាំងអស់គ្នាមិនបាច់ធ្វើអីប៉ុន្តែអ្នកទាំងអស់គ្នាត្រូវចាំអានេះបន្តិចដែរ delta 1 និង delta 0 ក្រៅពីហ្នឹងយើងពិភាក្សាគ្នារឿងថាតើដូចខ្ញុំនិយាយអញ្ចឹងគឺក្នុងមេរៀននេះមិនមែនទេមក course ហ្នឹងគឺយើងជជែកគ្នាថាធ្វើម៉េចដើម្បីឲ្យបាន delta ដែលល្អបំផុតយើងចង់កណនាអំពី effect របស់ x on y អញ្ចឹងយើងចង់បាន delta 1ដែលល្អបំផុតអញ្ចឹងមេរៀនហ្នឹងនិយាយទៅរឿង delta 1ឯមែនទេទៅប៉ុន្តែដើម្បីបាន delta 1ហ្នឹងយើងមាន assumption ផ្សេងគ្នាដោយអាកន្លែងហ្នឹងអញ្ចឹងដើម្បីយើងកណនា delta 1 និង delta 0ឥឡូវហ្នឹងយើង minimize u អញ្ចឹង assumption ទី1របស់យើងឲ្យ assumption u ស្មើ0បាទអញ្ចឹងវាទៅម្ដងម្តងតើនេះអញ្ចឹងអ្វីដែលអ្នកនរគ្នាត្រូវកុំបារម្ភពេកអ្វីដែលខ្ញុំព្យាយាមបញ្ចូលអ្នកនរគ្នានៅក្នុង course មួយហ្នឹងគឺ connect ពី theory ទៅក្នុង apply ហ្នឹងគឺយើងប្រើអាណាយើងត្រូវការអាណាហើយធំជាងគេតែខ្ញុំចង់បញ្ចូលអ្នកនរគ្នាក្នុងមេរៀនហ្នឹងគឺថាតើពេលអ្នកនរគ្នាចង់កណនាបែបនេះថាតើមានបញ្ហាដែលអ្នកនរគ្នាត្រូវដោះស្រាយឧទាហរណ៍យើងនិយាយថាយើងចង់ delta 1 ហើយយើងចង់ make causal interpretation យើងចង់និយាយថាបើសិនបើអ្នកទាំងអស់គ្នាបង្កើនការអប់រំមួយឆ្នាំថាតើប្រាក់ចំណូលរើបានប្រមាណអានឹងគឺជា concern របស់ economics គេដើម្បីកណនារើអា delta ហ្នឹងឲ្យត្រឹមត្រូវបានថាតើយើងមានបញ្ហាខ្លះដែលយើងត្រូវការយកចិត្តទុកដាក់អាហ្នឹងគឺជាអ្វីដែលយើងពិភាក្សាក្នុងមេរៀនហ្នឹងម្ដងប៉ុន្តែក្នុងសប្តាហ៍ហ្នឹងឥឡូវហ្នឹងអ្នកទាំងអស់គ្នាត្រូវចាំមិនបាច់ memorize ក៏បានប៉ុន្តែ take note ឲ្យទៅពេលជា delta 1 and delta 0អ្នកគ្នា refer to the note របស់អ្នកទាំងអស់គ្នាវិញអញ្ចឹង is that okay?
Yes, lecturer, yes.
Don't worry about that much, okay? As I said from the beginning, I don't focus much on math. So step by step. And one of the things that you may not fully understand in English, one way is the term itself. So make sure you follow the terms I try to emphasize. Like when we talk about residual or error term. Residual is for sample and then error term is for population. So step by step. If you don't understand anything, as I said, don't be silent. Just ask the questions. Okay? So now this is the equation derived from OLS. At least as an economic student, when we refer to OLS, you should know. Okay? What do we mean by OLS? OLS is the estimate that we try to minimize some observation in order to generate delta 1 and delta 0. Okay? Next. Questions for now? So now you all know what is the equation to generate delta 1. What is the equation to generate delta 0? All right? So the difference between delta 1 hat and delta 1 is that delta 1 is for population and we call parameter. Delta 1 hat we call also the slope, but slope estimate. That estimate it for sample. All right? So from the beginning, we want delta 0 and delta 1. Now we already have delta 0 and delta 1. Next, here, okay? If we use OLS,ខ្ញុំនិយាយខ្មែរសារយើងអត់មាននេះខ្ញុំឲ្យអ្នកទាំងអស់គ្នាយល់កន្លែងហ្នឹងសិនដោយសារតែយើងប្រើរូបមន្ត OLS ហ្នឹងដោយសារយើងប្រើរូបមន្ត OLS ហ្នឹង dương vậy tham mấy dương phi dương minimize sum of sphere một residual này chẳng được bên là dương minimize sum of sphere một residual nắng cứ dương anh vậy ban tha align với này line là dương cái này equation là perfect OLA nắng cứ chỉ line đây là O một chỉ line đây dương produce lowest sphere sum residual okay line cái line là O một hay line cái hai fitted regression line okay fitted regression line chẳng út cho ho tha y ní y nó lên line ní chỉ y để dương cái này để pra equation này tapi y I1 នេះគឺជា y ជាក់ស្ដែងដែលយើងសួរអីគេដែលយើងសម្ភាសពី respondent ឧទាហរណ៍តែយើងសម្ភាសរឿងគាត់រឿងប្រាក់ចំណូលដែលគាត់រើបានថាតើមួយខែរើបាននេះគឺជាប្រាក់ចំណូលជាក់ស្ដែងតែពេលអានេះគឺជា y ដែលយើង calculate ពី equation មួយនេះយើងរើឃើញ delta 0យើងបូក delta 1ហើយគុណជាមួយនឹង education របស់គាត់ហ្នឹងអានេះយើងហៅថា real residual នេះគឺជា y ដែលយើងរើឃើញជា y hat ហ្នឹងយក y ដែលជាក់ស្ដែងដល់ y hat ហ្នឹងវាជា residual ហើយ residual ហ្នឹងវាអាច negative ហើយនិង positive ឧទាហរណ៍ដូចសម្រាប់អ្នកដែលនៅកន្លែងនេះគឺគាត់មាន negative residual អ្នកដែលនៅលើនេះគាត់មាន negative positive residual អញ្ចឹងទៅអូខេនេះជាឧទាហរណ៍ okay now let me turn to English all right so here for example you want to know the relationship of the effect of return on assets, return on equity of CEO firm on salary. You want to know, is there really a positive relationship or negative relationship, or what is the effect of return on equity on salary? Okay, this is your equation. But as we already know, in order to find delta 0 and delta 1, we try to minimize the sums of residue. And now we get this. Okay, this is the intercept. This is the coefficient. This is what you want the best. You want best. All right. Given the sample, the survey sample, you get this. And how you get this delta 1 and delta 0? From this equation. You know x, you know y. You can compute for x bar and y bar. Then you can, of course, calculate this. But after the break, we will do a small hand-on exercise in this data. It's very quick. All right. So here, if you look at this interpretation, if return on equity increased by 1%, here the return on equity is measured in percent. All right. Then the salary is predicted to change by $15,000. Right? This equation. But if you look at here, the way they interpret it, they interpret in Gaussian interpretation. Why? Because they specify the amount of value. The question is, can you make Gaussian interpretation? No. Why? The conditional mean independent assumption is violated. Okay? Conditional mean assumption is violated. And what is that intercept? This intercept means that if there is zero return on equity, the salary of CEO is about this, 963 USD. If on average the return on assets is zero, so at least the CEO could earn this monthly salary. But if there is more and more return on asset, their salary will be plus this multiplied by return on asset. But what we see here is that there is a positive relationship between return on equity, not asset, and salary. The higher return on equity, the higher salary CEO gets. Hello? I was disconnected again. for a few seconds. Can you see the share screen?
Yes, lecturer.
Question, can you follow the interpretations? Can you follow me?
Lecturer, my internet got cut off when you were explaining
all right,
the meaning. Yes.
All right.
So can you
Again.
explain that?
So let me say in Khmer again, in case some of you like it. All right. Here, này cứ dương trong ưu tiêu này cứ dương trong mưa pi tận nhẹ tận nó bảo return on equity cho mùi nắng bạc hai bảo CEO. Okay. Chẳng ní bởi dương thưa survey dương sầm pia CEO nó nhưng xua pi salary bạc quát nhưng xua pi return on equity bạc quát mình chẳng. Là bây giờ xua pi năng hái làm bay kẹt này pelta zero and pelta one dương aside từ lưới hụp môn pi này mình chẳng ấy kẹt này pelta one bàn này bàn pelta one dương ai kẹt này pelta zero bàn bàn pelta năng hái dương tranh này nó chỉ pelta zero nó chỉ pelta oneแต่บงพอดเอาไว้เดี๋ยวยังจับอารมณ์ยังไงแมน pelta zero นะยังจับอารมณ์ยังไงคือ pelta one จะมีคนปรับตื้อปังหานปีตันเนี่ยตันน้องใน x แต่ในขนมนี้คือ return on equity ให้นาง y จังเอาไว้เดี๋ยวยังเคยยังดังท่าโดยซาตานี่วิวิจมีนยังเคยทำไหมวิมีนตันเนี่ยตันน้องวิจมีนปี return on equity ให้นาง salary อันนั้น return on equity การนักพัวอยากขาย CEO การเฉยขนมนี้เก็บบอกแพยังเพียบให้ทำ percent บา return on equity นั้นการลาวมวยเพียร้อยอยากขาย CEO การลาวบอกใบป่วนนะบอกใบป่วนแต่ซานี่จีเพียรถโอเคบอกใบป่วน intercept นั่งมาถ้าจีเมจีขมายให้ทำใบที่ยังพลิกบาได้ตีดับปีวิธีจำนวนเทนั่งมาให้แบบยืงท่า percent บา return on asset นั่ง equal is zero แต่เราว่าถ้าแผกแค่บอก CEO นั่งอย่างเต็กก็บานปนังได้ตัวใบอดมี return on asset ก็แผกแค่ CEO ก็จับดามปีผมบัวเลย60ใบได้ตอนยังไงจัง delta zero นั่งแผกยืงคือเชียตรงนี้เบอร์ยืงก็ได้ return on asset zero นี่คือเชียแผกแค่อย่างเต็กก็แผกแค่บอก CEO ในขนม sample เลยยังบานสัมเพียนั่งคือปนังโอเคชีมัดชมเบอร์ return on asset zero มี return on asset นั่นก็กวาดอาจเหอบานผมบัวเลย60ใบดอลลาร์ return asset การล้างแผกขายก้อนการล้างตามจำนวนนี่เปอร์เซ็นต์ return asset การล้างม้วยอย่าม้วยคนในเมฆคนปรับตื่นนั่นบางคนปีบางการปีอย่าปีนั้นคนในเมฆคนปรับตื่นนั่นจึงเหรอเคยปีแผกขายบ่ CEO Can you follow me
ใช่ so beta one นั่นคือจำนวนในการล้างเหมือนเช่
beta one นั่น yes beta one is the coefficient which you make คนปรับตื่น Hello can you hear me
Yes I can hear now lecturer I can hear now
Alright beta one นั่นคือเมฆคนปรับตื่นในยังจงแกะนี่จังโดยยังจะมียังตั้งปีดามยังทายยังจงแกะนี้ยังจงแกะนี้เหรอ affect บ่ x on y จังเปอร์เซ็นต์ยังเมื่อนั่นคือยังจงบานเมฆคนเนี่ยยังจงดังทาตาx นั่นวิ affect y กำลังปัญหาเบอร์ x increase by 1 unit อุทธรณ์นี้ unit which percent ยัง y นั่นคือวิแปรปรวนตามเมฆคนปรับตื้อหรือบ่ return on asset เนี่ยอันนั้นไปยังยี่ปีอันนั้นสมัยกาเดกเรที่มวยยังไปยังยืนนำที่ดับปีในปัญหาการนั้นยังดังแต่ยังเยอะไปมาปราแบบไหนยังชลาวสมนุบอกคิมฮู
นั่นไงเช่เจ้าปีหมกbeta zero นั่นคือแผกแค่บอกกดมองเธอเช่
แผกแค่beta zero นั่นยังเหมือนจะแผกแค่ยังจะแผกแค่บอกเธอยังยืนถ้าน้องกัดในได้ return on equity คือ zero ไปยังเยอะ return on equity zero จังไปยังเยอะ zero มาคนมวยมีคนปรับตื้อเป็น zero จังขนมกัดในได้อดมีน return on asset ซะก็แผกแค่บอก CEO นั่นจับดาวปีบ้านปันนังได้ที่มาชมในขนมจะหนาว CEO ในยังบ้านสัมเพียนั่นเลยอันนั้นเป็นแม้จะ simple มีนโดยยังทั่ว descriptive statistic descriptive statistic กิมหัวจำไม่ยังไปยังทั่วจะ average ไม่จากนั้นถ้าเอาเชี่ยมาชมแบบขายกวาดบ้านมาก็อันนี้แม้เป็นในจังไงอันนี้มีในถ้าเปอร์เซ็นต์บอกอดมีใน equity ซะก็แบบขายก็จับดาวปีปันนังได้ toàn làm gì ấy
toàn chờ
ប៉ុន្តែដូចខ្ញុំជំរាបអ្នកទាំងអស់គ្នាមិនបាច់ pay attention ទៅ delta 0ទេនៅក្នុង regression បើអ្នកទាំងអស់គ្នាអាន paper កាន់តែច្រើនគេមិនដែល report delta 0ចូលនៅក្នុង research paper គេសំខាន់ជាងគេអា delta 1នេះយើងចង់ estimate delta 1នេះយើងចង់ estimate 18.501នេះអានឹងបានជាគោលបំណងសំខាន់របស់យើងអារឿងហ្នឹងបានធំជាងគេអញ្ចឹងបានយើងឃើញនៅក្នុងនេះគេអត់សូវ interpret ទេគេអត់ខ្វល់ទេសំខាន់គឺថា delta 1 pay attention to delta 1ទៅបានហើយ in short ណា clear question class
ចុះអា beta 0ហ្នឹងជាទូទៅអាហ្នឹងយើងទទួលអាហ្នឹងបានពីការ interview របស់យើងឬមួយអាហ្នឹងគេឲ្យមកស្រាប់ឈើ
ខ្ញុំជំរាបភាសាទៀតយើងមាន x and y អូខេ delta 1 and delta 0គឺបានមកពីយើងកណនាខ្លួនឯងនេះ delta 1យើងកណនាដោយប្រើរូបមន្តនេះតែពេលយើងរើបាន delta 1ហើយយើងកណនា delta 0អញ្ចឹង delta 1និង delta 0គឺជាអ្វីដែលយើងត្រូវកណនារកអ្វីដែលយើងមាននៅក្នុងដៃគឺយើងមានតែ x and y ឯងបើយើងមើលរូបមន្តណាមួយនេះដើម្បីកណនា delta 1យើងត្រូវការ x ហើយនិង y ហើយយើងយក x and y យើងកណនារក x មធ្យមឃើញហើយយើងកណនា y មធ្យមឃើញដូចគ្នាអញ្ចឹងនៅពេលយើងមាន x យើងកណនា x មធ្យមយើងអាចកណនារក delta 1បានបើមិនយើងមើលរូបមន្តខាងក្រោមនេះមិនអញ្ចឹងពេលយើងបាន delta 1ហើយយើងយក delta 1ហ្នឹងមកកណនា delta 0អញ្ចឹងជារួម delta 1ហើយនិង delta 0គឺជាតម្លៃដែលយើងចង់កណនារកតើ
Yes sir yes
okay so again the most important part that you guys need to say memorize or need to understand is delta 1 the coefficients in Khmer we call មេគុណប្រាប់ទិសការទី12យើងនិយាយថាវាជាមេគុណប្រាប់ទិសពាក្យថាមេគុណប្រាប់ទិសនោះមានន័យថាម៉េចមានន័យថា x and y តំណាក់តំណងរឿង x and y ហ្នឹងវាអាស្រ័យទៅលើអា delta 1ហ្នឹង delta 1ហ្នឹងវាប្រាប់យើងពីតំណាក់តំណងពីអា x and y ហ្នឹងបើ delta 1វិជ្ជមានបានថាបើ x កើនឡើង y ក៏កើនឡើងដែរ x ហ្នឹងគឺជាប្រភពដែលធ្វើឲ្យ y ប្រែប្រួលបើមិនបើមេគុណប្រាប់ទិសហ្នឹងវាអវិជ្ជមានកាលណា x កើនឡើង y ហ្នឹងគឺវាថយចុះវិញ okay I spoke in Khmer I hope you guys understand me somehow okay is that okay for now all right I believe your brain is burning now I understand so now let's time to have 30-minute break now it is already 6:48 so 30-minute break please return back to the class or to the room at 10 minutes 7:20 is that correct right this is
yes.
now 49 okay please return back to the room at 7:21 30 minutes sharp I see you after break
Thanks, sir.
Hello, class. Are you back in the room?
Yes, lecturer.
All right. So let's continue. So this is the last slide before our break. So we found the delta 0 and delta 1 for the equation of return on equity for salary. So based on this result, we can draw a graph, assuming this is the salary. So when there is no return on equity, as you see on the graph, the vertical axis is for salary, the horizontal axis for return on equity. So when there is no return on equity, the CEO salary starting with from 963, and when the return on asset increased by 1, blah blah blah, and this is the equations, the fitted regression line. Okay, the fitted regression line depends on return on equity, and this dashed line is the unknown population regression line. So this is not known, okay, unknown, but we assume that this line is like this. Why do we know that? Because now if you will learn more, you will understand it in the future. If you add more and more controlling variable, you will see that the effect on the relationship, the slope here will become smaller and smaller. That is why the unknown population regression line is not that flatter as the fitted regression line. Now let's move to another example. Again, I just want you to know how to interpret delta 0 and delta 1, but mainly we only focus on delta 1. Okay, delta 1. Now, if you want to assess the effects of education on wage, assuming that, as I informed you earlier, it is very important to know the unit of dependent and independence. Okay, assuming the wage is measured in hourly wage in dollar, and education is measured in year of education, because both variable must be numerical. Okay, now based on the survey sample, we collect data from N observation. We have wage data, we have education data. Now we calculate delta 0 and delta 1. So what we see here is that there is a positive relationship between education and wage. Specifically, if education measured in year of education, if education increased by 1 year of education, wage increased by 0.154. As you can see here in the sample, 1 more year of education was associated with increase in hourly wage by 0.54, right? So based on this slope estimate, why I say slope estimate, this is from sample. But should we or could we make causal interpretation again? No. Why? Because we only have one independent variable. The other variable that not included in the model may affect wage and also correlate with education. Our earlier example is intelligence. So this 0.54 here may also include the effect of intelligence. All right. So just a different example. Here another example to help you understand more. Here's about percentage of vote a candidate get. For instance, you want to understand the politics, you can use this to understand it. Okay. And this is the percentage of campaign expenditure on candidate A. How much candidate A spends compared to the other total expenditure, and how much percentage of vote a candidate A. And based on this data, the data on vote A and CIA, we found that there is a very high coefficient. If candidate A share of spending increased by 1% percentage points, he or she receives 0.46 percentage point more of total vote. Okay, so this is the relationship and the interpretation of delta 1. question class about delta 1. So again, remember this mathematical equation of delta 1 and delta 0. And then based on data, okay, data that you survey from respondent on X and Y, you can compute delta 1 and delta 0. And again, please pay more attention to delta 1 because it tells you the relationship, the effect of independent variable on dependent variable. Question class? Is that clear with the interpretation of delta 1? Any question
Lecture.
before we move on? Yep.
I have a question. So since you mentioned that the variables need to be numerical, so what about some variables like inequality and poverty? So like it's not numerical at all. So how can we study the relationship?
We will discuss that on another topic. We will have a topic on that. Okay, for now we just need to look at the relationship between two numerical variables first. Okay, for instance, poverty, if they are poor or non-poor, we have different interpretation, and we have different model for it.
Oh, okay, lecture. Yes. Okay.
Right. So this is the starting point. For now, just we need the relationship between two numerical variables. Good question. We will cover it in the next or following lecture. All right. So now let me move next. Then let me finish the slide before we move to data applications. All right. So after the regressions, after what we found delta 0 and delta 1, and we have x, we can estimate delta 1 hat. Again, what is delta 1 hat? Delta 1 hat is the y value that is predicted from this equation. Okay, not actual y. Okay, so delta 1 hat is the y that computed from this equation. Okay, we call it fitted or predicted value. Class, it is important to memorize. I say memorize the term. Otherwise, you cannot follow me. Okay, fitted or predicted value. The fitted or predicted value is computed from this equation. All right, and residual here or deviation from regression line is the actual y minus fitted or predicted value. As you can see, that is why we call it residual. Why? It is the difference, the deviations of actual y, the y that we collected from sample, minus y that we computed from equation. That is deviation from regression line, or technically we call it residual. Okay, residual. Okay, so importance property for our equation. This is just you need to know. Okay, as I said from the beginning, the summation of u of residual is equal 0. Okay, the summation of residual is equal 0, and here we need to so here what does that mean? This is the deviation from regression line sum up to 0. It have to be 0 because we try to minimize sum of square. And the correlation between deviation and regressor is 0. This is the independence, the unconditional independence assumptions that we discussed it earlier. And we need to make sure that our sample array of y and x are linear, are aligned on this regression line. Okay, this is something we already know, and this is we discussed it earlier. Don't worry, we will see it again next week with the a clear assumption, and then I will try to explain you more in detail. But here, based on this data, assuming data, okay, on the relationship between return on asset and salary, this is assuming that we conduct survey with 15 respondents. All right, we conduct survey with 15 respondents. We collect data on return on equity. We collect data on salary. Okay, based on this equity and salary, we constructed, we find delta 0 and delta 1 earlier. You remember that we have delta 0 and delta 1 from these equations, right? This is delta 0, this is delta 1. Based on this delta 0 and delta 1, we can calculate salary head. What is salary head? Fitted or predicted salary. Okay, this is the actual salary from our respondent. This is the salary head from this equation. We already found delta 0, we already found delta 1, then we can calculate this y head here. For instance, in this case, the actual y from survey is only 1,000, but based on equation it is about 12,000. And the difference between salary and salary head, we call U head here. This is the residual. The difference between 1,094 and 12,064. This is around minus 70. This is the residual. Okay. Here, this is the equation for fitted or predicted value, and this is the equation for residual. And this is how it looks like in the real data. Can you follow me with this summary table? We have X, we have Y, and then we calculate predicted or fitted Y from the equation, and then we can calculate the residual. If you sum all the residual, if you only have 15 respondents, it's gonna be 0. Follow me? All right. Any questions? All right, let's move on. Now, class, what we discussed so far is the relationship between X and Y. The relationship between X and Y. How much Y change if X changed by 1 unit. But so far, we do not know exactly how much X explain Y, or how much the model explain variation in Y. Let me speak in command. Okay. អ្វីដែលយើងបានពិភាក្សាគ្នាមកដល់កន្លែងហ្នឹងយើងនិយាយគ្នាទៅរឿងតំណែងឬក៏ផលប៉ះពាល់ឬក៏ affect របស់ X ទៅលើ Y ឯងអ្វីដែលយើងព្យាយាមកណនាមកដល់កន្លែងហ្នឹងគឺយើងព្យាយាមកណនាថាប្រសិនបើឧទាហរណ៍ដូចជាការអប់រំបើការអប់រំគាត់កើនឡើងមួយឆ្នាំថាតើប្រាក់ចំណូលឬក៏ប្រាក់ខែរបស់គាត់កើនឡើងប្រមាណយើងពិភាក្សាគ្នាទៅរឿងហ្នឹងឯងប៉ុន្តែ so far យើងអត់ទាន់បានដឹងថានៅពេលដែល regression របស់យើងគឺយើងហៅថា model របស់យើងហ្នឹងដែលមានតែ x តែមួយដែលមានតែ independent តែមួយហ្នឹងវាល្អប៉ុណ្ណាឬក៏ថាវាអាចបញ្យល់នៅពេលដែលយើងប្រើប្រាស់ regression ដែលមានតែមួយដែលមានតែ x មួយបញ្យល់ទៅលើ y នេះថាតើវាបញ្យល់បានប្រមាណភាគរយបើយើងនិយាយសាមញ្ញថាតើនៅពេលដែលយើងប្រើ return on asset តែមួយមក explain salary ហ្នឹងវាបញ្យល់បានប្រមាណភាគរយអានេះគ្រាន់តែជាតំណែងវាមិនមែនបញ្យល់ពី model ទេអញ្ចឹងយើងត្រូវនិយាយគ្នាយើងត្រូវជជែកគ្នាពាក្យបច្ចេកទេសគេហៅ goodness of fit. What is goodness of fit? Goodness of fit tell us how well does explanatory variable explain independent variable. វាប្រាប់យើងថាតើ model យើង regression ដែលយើងប្រើ x តែមួយហ្នឹងឬក៏ model យើងជាក់ស្ដែងប្រើ x ប្រមាណហ្នឹងវាអាចបញ្យល់នៅ dependent variable បានកម្រិតប៉ុណ្ណាអូខេអញ្ចឹងដើម្បីស្វែងយល់អាហ្នឹង Hello អ្នកនរគ្នាឮខ្ញុំទេ
Yes, lecturer.
All right អញ្ចឹងដើម្បីស្វែងយល់អំពី goodness of fit ហ្នឹងគឺយើងត្រូវការស្វែងយល់ពាក្យបច្ចេកទេស3ទៀតគេហៅ total sum of share ហ្នឹងគណនាបែបណា យើងយក y ដែលយើងសម្ភាសពី respondent ហ្នឹងដូរឲ្យ y bar ឯគេអ្នកនរគ្នាចាំទេអាចឆ្លើយប្រាប់ខ្ញុំក៏បានដែរឲ្យតែចាំខ្លួនឯង y bar ហ្នឹងគឺជាស្អីគេគឺជា min របស់ y មធ្យមទូទៅមធ្យមដែលយើងកណនាធម្មតាហ្នឹងអញ្ចឹងនៅពេលដែលយើងយក y actual ជាក់ស្ដែងដកឲ្យ y bar ហ្នឹងអាហ្នឹងគឺជាអីគេស្វែហ្នឹងវាគឺជាអីគេ total sum of square បើអ្នកទាំងអស់គ្នាចាំអាហ្នឹងគឺជាអីគេគឺជា variance របស់ y ហ្នឹងខ្លួនឯងអញ្ចឹងអា total sum of square ហ្នឹងវា represents total variation independent variable okay independent not independent okay អញ្ចឹងបានថាវាបង្ហាញអំពីការបញ្យល់ទូទៅលើ y តែឯងមួយទៀត SSE ស្អីគេ SSE ហ្នឹង SSE គឺ explain sum of square explain sum of square កណនាមិន y hat ស្អីគេ y hat គឺជា fitted ឬក៏ predicted y យើងរើវាមកពីណាយើងរើវាដោយសារតែយើងមានអា model មាន equation ហ្នឹងយើងរើ delta 0ឃើញហើយយើងរើ delta 1ឃើញហើយផ្អែកទៅលើ equation ហ្នឹងយើងអាចកណនា fitted ឬក៏ predicted y បានអូខេអញ្ចឹង predicted fitted predicted y ដកឲ្យ y bar min របស់ y ហ្នឹង sphere ហ្នឹងយើងកណនា explain sum of sphere ស្អីគេ explain sum of sphere explain sum of sphere ហ្នឹងគឺវា represent variation explained by regression មានន័យថាម៉េចយើងចង់និយាយថាអា regression ដែលយើងប្រើ x តែមួយហ្នឹងវា explain y ប្រមាណភាគរយគឺយើងចំណាប់អារម្មណ៍យើងចង់មើលអាហ្នឹងយើងចង់រើ SSE ហ្នឹង explain sum of sphere ប៉ុន្តែទៅជួទៅនៅក្នុង regression យើងរើយើងពិបាករើ SSE ហ្នឹងអញ្ចឹងយើងត្រូវរើមួយទៀតយើងត្រូវរើ SSR what is SSR SSR គេហៅថា residual sum of sphere residual យើងអាចរកបានគឺ residual sum of sphere មកពីណាគេមកពី mu hat ហ្នឹង mu hat ហ្នឹងយើងរើវាតាមណាចាំទេគឺ y ដកឲ្យ y bar ចាំទេ mu hat ហ្នឹងគឺវាស្មើឲ្យ y ដកឲ្យ y មិន y bar សំទោសគឺ y hat y ដកឲ្យ y bar គឺជា total sum of sphere y ដកឲ្យ y bar sphere វាគឺជា residual sum of sphere អញ្ចឹងវា represent variation not explained by regression SE ហ្នឹងវាប្រាប់យើងថាតើអា model របស់យើងហ្នឹងវា explain ប្រមាណដល់ពេល SSE ហ្នឹងអាផ្សេងដែលអត់ explain អញ្ចឹងដើម្បីកណនា SSE គឺយក SST ដកឲ្យ SSR ច្បាស់កន្លែងនេះអញ្ចឹងមែនតើទៅ SST total sum of sphere វាស្មើឲ្យ sum of sphere explain plus ឲ្យ sum of sphere residual អូខេអញ្ចឹងអា total variation ស្មើអា explain បូកឲ្យអា odd explain អូខេអញ្ចឹងដើម្បីងាយស្រួលយល់យើងអាចចែកអាទាំងអស់ហ្នឹងយើងអាចចែកអាតួអង្គទាំង3ហ្នឹងនៅលើដោយទៅ SST អូខេចែកដោយ SST នៅពេលយើងចែក SST យើង rearrange equation ហ្នឹងទៅ SST នៅលើ SST វាមិនស្មើមួយដកឲ្យបើសិនបើយើងចង់រើ SSE លើ SST វានឹងសល់ SSR នៅលើ SST អាហ្នឹងគេហៅវាថា SSE នៅលើ SST នេះគេហៅវាថា goodness of fit measure ឬគេហៅដោយខ្លីថាជា R sphere អូខេហើយ R sphere ហ្នឹងគឺវា measure នៅភាគរយដែលវា explain ឲ្យ dependent variable របស់យើងវានៅចន្លោះពី0ទៅ 1% ព្រោះអាហ្នឹងវាស្មើ1ដកឲ្យ SSR នៅលើ SST alright ជាឧទាហរណ៍អូខេជាឧទាហរណ៍យើងដឹងហើយថាតើ SSR នឹងមកពីណានេះរូបមន្តរបស់ SSR រូបមន្តរបស់ SST គឺបែបនេះអូខេអញ្ចឹងយើងកណនាវាមកតាមរូបមន្តហ្នឹងយើងអាចកណនារើ SR sphere បាននេះអ្វីដែលខ្ញុំចង់បញ្យល់អានេះយើងជជែកគ្នាពីដំបូងអានេះ delta 0អានេះ delta 1ឥឡូវឧទាហរណ៍តែយើងកណនាមិញហ្នឹងគឺយើងមាន respondent 209យើងរើឃើញ R sphere ស្មើនឹង 0.0132 មានន័យថាម៉េចនេះគេបញ្យល់ថា regression របស់យើងដែលប្រើ x តែមួយទៅលើ salary ហ្នឹង គឺវាបញ្យល់បានតែ 1.3% នៃ total variation របស់ salary មានន័យថាម៉េចមានន័យថា model ដែលយើងកំពុងសិក្សាអំពីតំណែងនៃ return on asset ទៅលើ salary ដែលយើងមានតែ return on asset តែមួយហ្នឹងវា explain បានតែ 1.3% ឯងចឹងមកថាវាមានកត្តាផ្សេងទៀតដែលវា explain salary ដែរដែលយើងអត់ដាក់នៅក្នុងហ្នឹងចឹងកត្តាផ្សេងទៀតហ្នឹងវាប្រហែលជា 98% ជាង 98.7% ទៀតដែលយើងអត់បានដាក់បញ្ចូលនៅក្នុង model ហ្នឹងតាន់ការបូកប្រែនៃ R square អ្នកនរគ្នាអ្នកនរគ្នាអាចអត់យល់ពី equation នេះអត់អីទេអ្នកនរគ្នាអាចមើលវាបានប៉ុន្តែសំខាន់ផុតឲ្យយល់អាខ្ញុំបូកប្រែ R square នេះខ្ញុំព្យាយាមនិយាយខ្មែរទៅជាងនិយាយអង់គ្លេសតោះនេះភាសាទៀតឧទាហរណ៍ដូចរូបមន្តដែលយើងកំពុងគណនា return on equity ទៅលើ salary ហ្នឹងយើងមិនប្រើតែ independent តែមួយអញ្ចឹងនៅពេលដែល model របស់យើងប្រើ independent តែមួយព្យាយាមសិក្សាអំពី relation ហ្នឹងគឺយើងដឹងហើយថាតើវាមានតំណែងវិជ្ជមានហើយវាមានផលប៉ះពាល់ប្រមាណតាម delta 1ប៉ុន្តែអាហ្នឹងអត់បានប្រាប់យើងអំពីការបញ្យល់ពី explanation ពី variation នេះ R sphere នេះវាប្រាប់យើងវាថាយើងយកគុណនៃ100ហ្នឹងវាប្រាប់យើងថាអា model ដែលយើងព្យាយាមសិក្សាអំពីតំណែងពី return on equity ជាមួយ salary ហ្នឹងនិយាយឲ្យខ្លីថា return on equity តែឯងនៅក្នុង model ហ្នឹង explain បានតែ 1.3% ទេចឹងវាមានកត្តាផ្សេងទៀតប្រហែលជាលើសពី 90% ដែលអត់បានយកមកគណនាឬក៏គិតគូរនៅក្នុង model មួយហ្នឹងទេតន់ខ្ញុំទេតន់
ចា
alright បើសិនបើយើងមើលឧទាហរណ៍ទី2វិញឧទាហរណ៍ទី2 R sphere ខ្ពស់វាប្រាប់ថាម៉េចបើយើងនិយាយអំពីការបោះឆ្នោតកត្តាដែលបញ្យល់ពីលទ្ធផលបោះឆ្នោតធំជាងគេគឺកត្តាចាយវាអញ្ចឹងនេះបើសិនយើងមើលអា simple regression នេះវាសាមញ្ញដូចអាលើដែរតែមួយដូចគ្នាប៉ុន្តែអា share នៃ A នេះគឺវាសំខាន់មែនទែនគេរកឃើញថាម៉េចរកឃើញថានៅពេលដែលយើងព្យាយាមសិក្សាពី relationship ពីអាការចំណាយទៅលើការបោះឆ្នោតទៅលើការឃោសនាបោះឆ្នោតអានឹងលទ្ធផលឆ្នោតដែលគាត់ទទួលបានប៉ុន្តែត្រូវចាំអា measurement របស់គេនេះអា unit របស់គេនេះមិនមែនជាចំនួនលុយទេណាជា share vote នេះគឺជា share ដែលយើងនិយាយជជែកគ្នាពីដើមទីឧទាហរណ៍ពីលើមកឧទាហរណ៍ពីកន្លែងមួយណាជា O salary នេះពីកន្លែងនេះ percentage of vote for candidate A និង percentage of campaign expenditure candidate A ហ្នឹងគឺយើងឃើញថាម៉េចយើងឃើញថាការចាយវាយទៅលើការឃោសនាបោះឆ្នោតនោះវាមានតំណែងជាវិជ្ជមានទៅលើចំនួនផលិតឆ្នោតដែលគាត់ទទួលបានប៉ុន្តែគេ measure វាជាភាគរយវាឃើញជាវិជ្ជមានមែនប៉ុន្តែគ្រាន់តែយើងចង់និយាយថា model ដែលយើងឃើញដាក់តែមួយហ្នឹងដាក់តែមក independent តែមួយឯងធ្វើពីលទ្ធផលបោះឆ្នោតបានសឹងតែបាន 85.6% ឯណោះអញ្ចឹងអាផ្សេងទៀតអត់សំខាន់ទេអ្វីដែលយើងឃើញថាម៉េចឃើញថាអាមួយនេះវាយល់បានល្អចំពោះលទ្ធផលរបស់យើងអូខេប៉ុន្តែចំណាំ high R square មិនមានន័យថាលទ្ធផល regression របស់យើងនឹងអាចបកប្រែដោយមាន causal interpretation បានទេណា R square គ្រាន់តែប្រាប់យើងថាតើ regression របស់យើងនឹងបញ្យល់ dependent variable បានកម្រិតប៉ុណ្ណាប៉ុន្តែអត់អាចប្រាប់យើងថាអូអា delta 1របស់យើងនឹងគឺយើង make causal interpretation បានទេមិនមែនមានន័យថាអញ្ចឹងទេអញ្ចឹងតួនាទីរបស់ delta 1 និង R square គឺរឿងពីរផ្សេងគ្នា delta 1ប្រាប់យើងអំពីតំណែងនៃ independent variable of interest x ដែលយើងដាក់ចូលជាមួយនឹង y ប៉ុន្តែ R square បង្ហាញពី variation ថាតើ model របស់យើងនឹងវាបញ្យល់បានកម្រិតណាទៅលើ dependent variable របស់យើងចឹងអាពីរនឹងផ្សេងគ្នាតើ I try to speak in Khmer hopefully you guys could catch up could understand what I just explained questions this is the last slide for the econometric we will move on to Stata and then I will quickly introduce you guys to how to get the result from simple linear regressions in Stata. But before we move to Stata, questions? Questions? Miền some new ấy. chẳngអ្វីដែលអ្នកទាំងអស់គ្នាត្រូវចាំ go ahead Kim Hua.
Yes, lecturer. So since the R square does not necessarily mean that the regression has a causal interpretation. So like when do we know that we can make a causal interpretation or we can make a conclusions on the relationships of two variables?
All right, that is a good question. And for now, what I'm saying, for now, the answer is that we cannot make causal interpretation with simple regression model. We cannot make causal interpretation with regression that has only one independent variable. And when can we make causal interpretation is when you know that the assumption of unconditional mean independence is met. និយាយជារួមមកវិញយើងអាចធានាថាយើងអាច make causal interpretation បាននៅពេលដែលអា conditional mean ដែលយើងជជែកគ្នាពីដំបូង assumption មួយហ្នឹងគឺវាអត់ violate នៅពេលដែលយើងធានាថា variable ទាំងអស់ដែលយើងដាក់ចូលក្នុង model ដែលសំខាន់ឧទាហរណ៍ថាបើសិនបើយើងចង់វាតម្លៃពី effect របស់ education លើ weight តោះតែយើងធានាថាអត់មាន variable ណាមួយដែល correlate ជាមួយនឹង education ហ្នឹងអត់បាននៅក្នុង U នេះតើតា assumption មួយនេះ myth បានយើងអាច make causal interpretation បានអាហ្នឹងចម្លើយខ្លីទៅនឹងសំណួររបស់គឹមហួរហើយដូចខ្ញុំជម្រាបអ្នកទាំងអស់គ្នាពីដើមអញ្ចឹងកុំថាតែ simple ឥឡូវនេះយើងសិក្សា simple regression 2-3 សប្តាហ៍ទៀតយើងនឹងសិក្សាពី multiple regression យើងដាក់ x ច្រើនជាងមុនទោះបីយើងដាក់ x ច្រើនជាងមុនដែរក៏យើងអត់ទាន់អាច make causal interpretation ដែរអ្វីដែលខ្ញុំនិយាយកន្លែងនេះគឺខ្ញុំចង់និយាយថា assumption នេះ conditional mean independent assumption ហ្នឹងគឺមិនងាយនឹងអ្នកទាំងអស់គ្នាអាច meet នឹង condition ហ្នឹងបានទេប៉ុន្តែយើងនឹងសិក្សាម្ដងតើតើធ្វើម៉េចដើម្បីយើងអាចដោះស្រាយឬក៏ធ្វើម៉េចដើម្បីយើងធានាថា conditional mean independent assumption ហ្នឹងយើងអាចធ្វើម៉េចឲ្យយើងគោរពតាមលក្ខខណ្ឌហ្នឹងបានអញ្ចឹងរឿងដែលសំខាន់ជាងគេដើម្បីឆ្លើយមួយសំណួរគឹមហួរគឺសំខាន់ជាងគេលើ assumption មួយហ្នឹងហើយ assumption មួយហ្នឹងមានន័យថាម៉េចដោយឧទាហរណ៍ intelligent ហ្នឹងអញ្ចឹងតើតែគឹមហួរឯងត្រូវបញ្ជាក់ថាគឹមហួរឯងចង់សិក្សាអំពីផលប៉ះពាល់នៃ education លើ weight ធានាថា variable ទាំងឡាយដែល affect weight ហើយ correlate ជាមួយ education ហ្នឹងគឺអត់នៅក្នុង U តែវានៅក្នុង U គឺយើងអាច make causal interpretation បានទេពាក្យថា make causal interpretation គឺយើងអាចបកប្រែឲ្យផ្អែកទៅលើលេខនេះបានទេយើងគ្រាន់តែនិយាយថា education មាន positive relationship មួយ weight ប៉ុន្តែយើងអាចនិយាយថា education កើនឡើងបានមួយឆ្នាំប្រាក់ចំណូលយើងរើបានប្រមាណលុយយើងអាចនិយាយអាហ្នឹងបានអាហ្នឹងហៅ causal interpretation ដែរតើនេះគឺមួយ
Yes, pretty clear.
All right. Right. So this is the most concern assumption for every economist. For every economist, this is the main concern. And I say again, in this lecture, we try our best to relax, to address these assumptions step by step. All right, step by step. Guys, make sure you do not confuse between delta ones, which is the coefficient estimate, and R square, which is, we call it goodness of fit. All right. So from today lecture on simple linear regression, the key message that you guys should remember is how to interpret delta 1 and R square, and at least try to know what is the equation for R square and what is the equation for delta 1 and delta 0. That's it from today. And another important is that causal interpretation. You cannot make causal interpretation because of the unconditional means, what? I don't remember it. Unconditional mean independent assumptions. And hopefully you guys understand what do we mean by conditional mean independent assumption. It means that all the other factors that affect weight and correlation should not be in U, should be in the model. All right. So let me stop here for the first part of simple linear regression. Next week class, we are going to discuss in detail about the detailed assumption of this OLS. All right. Questions before we move on to Stata? Question, class? How are you now? All right. All right. Zooming, no question yet. Now let's turn to data. Once, please open your PCs and open your data. And then, can you hear me? Can you hear me?
Yeah, teacher, yes.
All right. All right. Okay. So it's time for data. Class? Open your
Teacher,
data.
do we open the same file as last week?
Right, right. We continue from last week. So now I go to my do file. I go to my last data do file. Okay. Sorry, not this one. Again, this one. All right. Everyone, please turn on your do file. Okay. Now I just run it from as yesterday. Click all and run. There should be no problem. The balance is wrong here. This is not balanced. You see, there is an error on my do file. It tells me something. So when I look at here, I found that this gender 0 here, it should be close bracket. So I found the error. So now I did it. And then I continue running. Gender not found. Gender not found. Oh, female. So there is no gender. So this variable name is name female. All right. Okay. All right. This is from last week. And then we discussed about generating new variable. And last week we stopped here. Generating new variable. Class. I hope you guys review what you learned last week. Any questions about replace from last week? Questions? All right. Since everyone is so silent, I assume there's no question. Before we continue our lesson class, let me quickly jump how we do the simple linear regression in Stata. And after that, we can continue our Stata lecture from last week. I just want to connect what you just learned before break and a little bit after break with this data applications. And then we move on, okay? Is that okay? Okay?
Yes,
So
teacher,
now
yes.
OLS. Right, OLS, simple linear regression. So in this case, you need to have a clear objective, a research question. So in this data, because I just want to make up, we will have a good example last week. I already prepared the file, but now with the available data that we have from last week, okay, the data from the science, social science score, assuming to know the relationship between reading and science score. All right, science score. So I want to know the effect of readings on science score. So in this case, I specify X is reading score and Y is science score. Follow me? So this is just a note to tell you. I have to specify X and Y. In Stata class, you can do it manually first if you don't know. So you go to Stata, but remember, what is your dependent, what is your independent variable, all right? So in my case, readings is the independent variable, science is the dependent variable. A quick confirmation again. Can you see the share screen? Can you see the whole share screen?
Yes, lecturer.
All right. So now assuming I want to estimate the effect of reading on science score. Okay, only assuming, right? All right. So I can do it manually first. I go to statistics. Everyone. Okay. Then I go to, be honest, I'm not familiar with manual click. I normally work on command and data. Okay, then you move to linear model and related. You move your cursor to linear model and related, and then linear regressions. Okay, so again, linear regression meaning that both X and Y are numerical variable. Probably before we run the regression, we can do summary. Okay, we can do a quick summary first, whether both variable are numerical. So you remember from descriptive statistics, we run summarize and then click read and science score. Okay, I copy and pass it on my do file. I want to know if they are numerical or not. Here, I see yes, mean, standard deviation, mean, and max. So both read and science are numerical or continuous variable. All right. So now again, I go to statistics, linear models, and related, then linear regressions. Okay. Following me. Then you click on it, linear regression. This interface appear. So you need to know here, dependent variable. What is your dependent variable? So in my example, this is what? This is science score. What is independent variable? In my case, this is read. All right. Then I click OK. Here is the result. For future use, I just need to copy, regress, science, and read, and save it in my do file. Okay, so I know that in the future, in order to run OLS or linear regression, I type regress, dependent variable followed by independent variable. Class, do you obtain the same result as mine? Does anyone have? Good. Does anyone have any problem with obtaining the result? I want to connect what you just studied and application first. Right.
I have different result, teacher.
Different result?
Because at the summary table, the total of my science only 195. I don't know why.
Oh, okay, I got it. Because here, from last week, I ran replace. All right, so I can run it original variable. It may be the same as yours. So let me use the raw data first. All right, wait a minute. So I will get the same as yours now. It's okay. Here I have, wait a minute. Summarize is 195. Read is 200. Now the result should be the same as yours. Is that correct?
Wait. Yes, it's the same now.
All right. As you can see, even though read has 200 observation, science has 109 observation. So when it work together, when you run the regression, it will only use the match observation, the observation that have both valid response for both variable. Okay, so here as you can see, we only have 195 respondent or observation. Okay, so now let me connect to what we just learned. So you learn about beta 0. Where is beta 0? Beta 0 is here. Constant. Look at coefficient column. Okay, just connect to what you just learned. Here is beta 0. All right. So if you really want to interpret beta 0, it does not make sense here. It says that if you do not have any score on reading, you will have score on science 20. Okay, it reading is like this. The interpretation is like this. That is why I told you that don't pay much attention to constant. Don't pay much attention to beta 0. This is the beta 0. And here is beta 1. Read coefficient here. What did you find? What is an interpretation class? So if assuming that you can make causal interpretation, if you can make causal interpretation, you say if your reading score is increased by one score of 1 unit, your science score will be increased by 0.59 or say 0.6. So there are a strong effect here from reading to your science score. Okay, if your score increased by 1, your score on science will be increased by almost 0.6. Follow me with these interpretations. Agree? From what we just learned, beta 1. Got it? But if we cannot make causal interpretation, we do not really interpret this number. So what we are going to say without causal interpretation is that we simply say reading has positive relationship with science score. We do not interpret the number, we just interpret the sign. All right? Follow me. Any questions? All right. Where is R square? You can see here R square. All right. So our model, which we use reading as the single independent variable to find the relationship with the science score, it explains science score about 39%. So there are about 62% more that the other predictor not in this model could explain. But in this model with reading, it can only explain about 38% of science score. Follow me? Okay, I stop here. This is what you just learned, beta 1, beta 0, and R square.
Sure, can you clarify again which one is beta 0 and beta 1?
Here, if you look at our equation, the beta 1 is the slope. of rate. So you look at here, this is the rate, okay, the rate. And then you look at the coefficient. So slope is the coefficient. So the coefficient for rate itself here is beta 1. And constant or intercept, it is the beta 0. Here, if you look at beta 1 is about 0.6. Can you see my highlight?
Yes, yes.
Right. So for today, only constant, rate, and R square only. Questions? So what you just learned from mathematical equation is quite complicated, but with hand-on exercise, it's very quick. But what important for you guys is that you need to know the interpretations and the problem. So the problem with this beta 1 is that we cannot make causal interpretation. This is the problem that we need to deal with along the way with this course. This course is just the beginning, all right? Not advanced. Can you follow me, everyone? Questions? Can you guys connect this result with what you have just learned on beta 0, beta 1s, and R square? Questions? This is the first part of simple linear regressions. The lecture will become more complicated and complicated from one week to another. Questions? How can we make causal interpretation? We need to make sure that the readings, the relationship between reading and sign, the reading is not correlated with error term. What we mean by error term, the other factor that is not included in this model. As you can see, in our model, we only have read. How about the other factor? What factor that may affect science score, but also correlated with reading? How do we know that? Only reading, only literature review could help you. Okay, literature review could help you. Because when you read more, especially economic paper, they will tell you what model they use, the data they use, and how they deal with the econometric issue. When I say econometric issue, it's just like the unconditional mean independent assumption. They try to address that problem. In the following lecture, you will learn another term we call omitted variable or endogeneity. In endogeneity, later you will learn about this term later. Okay, but again, it's still about these assumptions. Questions, problems with data, interpretations?
No from me, teacher.
Right. Let's just wait a minute. If someone want to ask the questions, class, if you remain silent, I cannot help. Ask the questions. If you have a doubt, if you want to have any clarifications, please ask. Don't be silent. You guys, your group will need to run this regression, multiple regression. At the end of this course, you will need to submit a research paper to answer the research question that you answered. You need to understand it. If not everyone, at least one member from each group. Questions? If not, I am going to return back to our slide on data, and then we're gonna continue from last week. We are going to move away from econometric and linear regressions for the last 20 minutes. Questions? No questions? I use YouTube to test the internet. Can you hear me?
Yes, sir. Here, sir.
All right. Then good. All right. So I assume that so far so good for everyone. Now let's return to our data topics. So last week we stopped at replace. All right, we stopped at replace. So now let me get back to the data lectures. So last week we were on replace. All right. So we use replace again to replace value of existing variable. When you have existing variable and you want to replace it, okay, you can replace it. And we discussed this last week. Now we move to the next slide. By the way, class, we use the last time's data, okay, the score of science. So we continue our lecture. So eGen is not something you should, all right, you should learn now. I will go only to some main points. Not here. Okay. Now we should learn about labeling variable. Okay. Oh, wait a minute. I don't think it is important for you now. I just only picked up some important for the a beginner. All right. I just only go to some. All right. You can go into detail with the slide. You will learn more. Okay. During our time, I only go into some main point. So here you can see you can use describe to understand the whole data sets of your data. Okay, you can just type describe. If you do not specify variable, it will describe the whole data set. Here, describe. So when you see float here, meaning that this data is numerical. Okay, numerical, but some variable you need to understand yourself. Okay, you can use describe. So if you describe, you not specify variable, it will describe the whole data set. But if you describe specific variable, you can just type the variable down, for instance, science. Okay, so it only describes these two variables. Okay, it describes these two variables. It is a little bit technical. You may not understand this for now, but don't just the nature of the program itself. So if you want to understand more, you have to look at data. All right, but this is the way you can describe your data. All right, I move a little bit quick. Not this one's tab, we already discussed it before. Now, let's discuss some dataset operation. All right, let's discuss some dataset operation. Dataset operation. Again, class, I only pick up some main points. For the detail, I suggest everyone to go into the reading material. Okay, go into the reading material. All right, now we move to dataset operation. Okay, we start with the variable list. Okay, so variable list, if you have variable here, class, for instance, you want to summarize all variable. Okay, rather than, if you remember, when we use summarize, okay, when we use summarize, we need to specify variable one by one. If you want to specify variable, if you want to summarize file, you have to specify variable like this. Okay, but there are another way that you can do it quickly. Constant here you I specify so source IN mat and write it and specify it. All right, another way to do it is you look at the order. Okay, I can specify from gender and then put a dash and then select the last variable. It has to be order. So when we have gender and dash to social and it means that from gender to social science. Okay, I copy it. So now let me summarize. Here, gender to social science. Then I click do. Here I get all the variables from gender to social science. So that's it here. No space, or it can be space as well. I'm not quite sure. Let me do it again. It's okay if you have space, but a dash here it means to, from gender to social science. Follow me? So if your variable is in order, you can just select the first one, dash, and the last one. That means that you can do all from the beginning to the last variable. Follow me, everyone. Any questions with the read dash to social? That we call variable list. Okay, a list from read to social science. Is that okay? Questions? Next. Summarize. Here, if we use, for instance, summarize R, and then start, summarize, sorry, R start. So it means that it only summarize variable that have R as the first letter. It doesn't matter what is the following letter, but you summarize all the variables that the name begin with R when you use R star here. Okay, here like this. All right, so summarize R star. So it only comes with read, erase, and read. Follow me? So star here meaning that the other thing is not important. So you only care about the first letter. It also the same if you want to specify the last. Okay, you can say star and then you specify the last variable, the last letter, for instance, the E. Is that possible to have this? Let's try it. Star E. No, it is not possible, I guess. It's also possible. Okay, all variables that ended with E. Start from star, anything ended with E. You start from R, anything that start with R. So star here represent anything else. But it's important is the end, you specify it, and the beginning, you specify it. Follow me? Questions? Or I am alone?
No, teacher, I'm okay.
All right. It's very Simple, easy. You can follow the slide quickly. All right. So here, to be more, conditional, you can A, start with A, anything, and then finish with E. This is for your confident use. All right. So you can specify everything here. Start with A and finish with E. We only have rest, not any other variable. Okay. All right. Next. We have about 5 minutes to 10 minutes left, but I don't want to go now. Another one is order variable. Order variable meaning you want to order from, if you look at this data set, you open data set, now it starts from gender ID. Now I want to start with ID. Okay, if you want to start with ID, you can put order, okay, order, and then type ID. And if you run it, you will see ID come first. Now change to ID first. So if you want to order variable in order that you want, then you can specify it order ID, then you want res, and then you want this. Any variable that you want to order, you want to put it first. It will rearrange it for you. That is order. Okay, that is order. It's important because sometimes when you want to do a summary from the beginning to the last, you need to order variable first. If after you order it, you just use the summary code from the beginning to the last. Okay, you want to order and then you run the summary for that variable. That is order. Okay, I don't go into detail with this one, just some important code. And here they ask, you can also sell data. This is the command, right? You can, this data, you can go directly, as I told you from the beginning, you can go and then sell data itself, sell S. So if you sell S this data, it will come like this, and then you specify the data name, all right? But the other way you can do it is that you can just write in code, you can say sell, and then specify file name, whatever I specified as Hyun. If you sell Hyun, it will sell automatically if there is no existing data named Hyun. But if there is an existing data named Hyun, you have to put comma and replace. So the replace here, if any existing data with Hyun, it will replace and store with this new name, with this new data set. That is sell and replace. Okay? Understand? Questions? Can you follow me? Can you, class? All right. If you are silent, I assume no. So we go next. Drop. Drop is used to delete some variable from your data. Okay. Here, if you look at this data set, and then you want to delete, for instance, I want to delete gender, then you just say drop. All right. And then gender. You look at the data set now. We have gender here in this column. Now I run drop gender. Then it will drop gender. Gender is no longer in the data set. Okay. If you want to drop any variable, you can specify more than one at the same time. Now I can drop school type. I drop program type. So I drop two variables at the same time. These two variables. Have a look here, and then I run it. Drop and then undo. Wrong. Tell me something wrong here. Variable SC type wrong. So I typed the variable incorrectly. So let me get back. SCHT no E. This one SCH no E. All right. Then I run it again. Look at these two variables. Then I run drop. Gone. Okay. Drop you to delete variable. Drop you to delete variable. Right?
Lecturer,
Yep.
how can we get it back if we delete it?
If you delete
If you
it,
want
then
to
you
get it.
cannot get it back. So that is why it is important for you guys not to sell and replace. So that is why, you know, for the economists like me, so normally we don't sell data. We start from using the raw data and then we clean it little by little. And then every time when we want the data, we just run the script. Okay, if you want to delete, just run the script, but the data is not stored. We do not sell data. That is why I don't sell data. Unless I know that everything is correct, then and I want to sell. But for now, I never sell data. Or if I sell it, I do not replace it. For instance, now our existing data is HS0. So if I want to sell it, I sell it into the new name. I sell it as. Okay. So now I can make it as HS0 new. So that it will not replace. It will not replace the existing data. Otherwise, like you asked, where can I get the deleted data? No, it's gone. So you have to make sure that if you sell as data, sell it as the new data so that you can extract any deleted variable in the future. Do we answer your questions?
Yes, lecturer.
All right, good questions. Good question. But again, if you guys use do file, it is not important to sell data for now, because every time you just run the script, it will get what you want, because you are not doing manual analysis that you do one by one. It takes a lot of time. With do file, you select all, you run. Right? So every time you start the do file, you come and do it again. So don't worry about that. But if you want to be quick, you can sell your data and then you can start from a new data again. It's up to you. So now, since you start working on data, you are a part of programmer now. A part of, even though we are not develop a code, but at least your analysis is a way of coding. Questions? Summarize out of order. I delete it. All right. Any other questions? I will stop here today. Question, class? All right. Any other questions? Questions? No? No questions?
Sure.
Yep.
So we want to import the table. We copy that to Excel. Is it right?
You mean this table? Right. So if you want to do it, you have to select it properly, like this. Can you? Oh, sorry. I forgot that I stopped sharing the screen. Wait a minute. Here. Can you see my share screen now? Can you see it?
Yes.
All right. If you want to work on this table, select on the table and right click and copy table. Don't just copy table. And then you can move to Excel. You can move to Excel and pass it in Excel and work on Excel, right? So now, like, I open Excel and then I pass it. Okay, this is how it comes. Then you can change the variable name in detail. That is social science. When you organize the table for your word file, this is science score, right? From the variable name to a full name, math, writings, something like that. So you can edit it in Excel. Is that okay?
Yeah, teacher.
All right. Thank you for the questions. Good question. I forgot that class. That is the end for this week lecture. You guys gonna have a homework, group homework. I will upload it into the classroom. Sorry, I will upload it into the team about the homework. So the homework, I will ask you guys to read the paper of your interest that you state another week. If you remember, the last homework, I asked you guys to formulate a research question and identify a paper of interest. And today homework, I'm gonna ask you guys to read that paper and find out some question. Okay, so please wait. I will send the homework to the group channel. That is all for today, class. Stay safe and take care. I'll see you next week.
Teacher.
Yep.
So what do you mean by finding the question?
Pardon, please.
Like your homework, you want us to find the question in the paper, right?
Sorry, you will see it. I mean that I will have some question that you need to read your paper to answer the question, not to find the question. All right.
Okay. Thank you, teacher.
Okay. Sorry for confusing. Bye-bye, everyone. Goodbye.
Goodbye, teacher.
Goodbye, teacher. Goodbye.